Right, I'm hoping this is going to respond soon. And I'm hoping now that everyone can see the slides. If there's any problems there, do shout. Okay, well, thanks very much, Mary. And hello, folks. It's a pleasure to be presenting the first of the IAEA's webinars today. As you can see from this slide, I'm from Ofqual, that's England's qualifications regulator. We at Ofqual, we oversee many, not all, but many of the organisations that offer qualifications in England. And we've got a system here in which the same qualification can be offered by multiple awarding organisations. So there is actually like a proper market for qualifications in England, which is why there's perhaps more of a need for a regulatory type body like us in England than in some other places. Now, when I joined Ofqual, and that was back in about 2014, we just announced our intention, as you can see here in blue on this slide, to put validity at the heart of what we do. Okay, and we decided we're going to clear out all of the rules and processes that might get in the way of that. And we concluded that we had lots of documents, particularly for regulating vocational qualifications, that did seem to perhaps get in the way of putting validity at the heart of what we do. But I think it's fair to say that at that point in time, we didn't really have an entirely clear sense of exactly what we meant by validity. So that was one of the first tasks that I got given really when I joined. It was to work out what we meant by validity and therefore what we meant by putting validity at the heart of what we do. Now, I guess that given that validity is our profession's most important concept, you'd think that ought to be fairly easy to work out what validity meant. But if any of you have tried, you'll know it's harder to do than to actually say. And I think it's because everyone's got their own particular view of what validity might mean. And some of those views, well, they're very different from other views. But of course, everyone thinks that their view is right. And I'm just going to illustrate that here with some definitions of validity that come from the educational assessment literature. So this is just to indicate how validity means quite different things to different people. Compare, for example, the first quotation I've got here, which is from the Ministry of Education in New Zealand. So that's saying that the validity of an assessment tool is the extent to which it measures what it's designed to measure. And I think that's a definition that many of us will be familiar with, kind of a very traditional definition, if you like. You've got a definition, though, right down at the bottom of this slide, where validity refers to the meaningfulness and the defensibility of the actions and decisions based on test scores, test-based information, or assessment reports. So you look at those definitions alongside each other and you think, well, they seem to be talking about quite different things. I mean, they don't even seem to agree on the kind of thing it is that's meant to have validity. Is it a validity of a tool or a validity of a decision? Does that make a difference? And because there's different reference in terms of what's meant to have validity, I think they indicate different meanings as to what validity is supposed to indicate. So it's all about measurement quality at the top, and it's all about meaningfulness and defensibility at the bottom. Yeah. So those are just two definitions. I've actually selected and ordered those definitions to give you kind of a transition to some that are more focused on tools, to others that are more focused on actions and decisions. But the point here is just to emphasize that there's loads of different ways in which validity is defined in the field. Okay. So I think that's part of what Joanna Gorin was getting at with her observation that she made back in 2007. So she said in an article in Educational Researcher, so consistently, the most challenging class of the semester for me to teach and for the students to understand is the one devoted to validity. Now, prior to me joining Ofqual, I'd been teaching at the Institute of Education in London. I was teaching a master's course in educational assessment, and I was definitely trying to put validity at the heart of that. And I certainly discovered that what Joanna said here was absolutely right. It really is hard to teach validity. It's not just all the different definitions that we've just seen on the slide before. It's all the different types of validity that crop up in the literature as well. So you'll all have heard of those, what you might call the classic holy trinity of validity. So content validity, criterion validity, construct validity. But it turns out the assessment literature is literally littered with types of validity. So I tried to count them a few years ago. Okay, and what I decided to do is, as I was reading through the literature on validity, which I was doing at the time, I'd record each new kind of validity that I found on an Excel slide. I found all sorts of weird and wonderful types of validity. So some of them will be more familiar to you, I'm sure, but some of them I'm sure will be very unfamiliar. I tried to highlight on the slide the ones that seem perhaps a bit more validity. So you'll have heard of construct validity, maybe discriminant validity, predictive, I'm sure you'll have heard of. But then there's all sorts of other different kinds of validities that I found. I'm just looking through the screen here. So fiat validity, what's that? Cross-age validity, cache validity, all sorts. I'd have found that I think there's 149 on the slide. I got up to about 149 and I kind of gave up after that. That's enough, I thought. Most of these, they aren't even synonyms. They're actually meant to indicate subtly different aspects of validity. Now, kind of just doing that exercise and assembling all these validities, it just made me think that there must be something wrong here. If nothing else, it made me think that the whole thing is extremely confusing and very confusing to teach. And I think that's what Samuel Messick also thought back in 1980s, 70s, 80s, into the 90s, when he said, it's far more sensible to think of validity, not in terms of lots of different types, but in terms of one type, basically, construct validity. And that's where you might have heard of the maxim nowadays, all validity is construct validity. But this is how he explained it, his unitary concept of validity. And we're not going to try and unpack this now infamous, I think, progressive matrix in any detail. I just want to make the observation again that it's kind of confusing. I mean, Stuart Shaw and I tried to unpack exactly what Samuel Messick meant by validity back in 2013-14 when we were writing a book on the topic. And I don't know that we really got to the bottom of it, but we gave it a good try. What I'm getting to, though, is the point that the bit about validity that I found hardest to explain to my students wasn't the things that we've seen so far, which, you know, they definitely are confusing. It was another aspect of validity that Samuel Messick popularized, which was his twin threats to validity. Okay, so that's construct under representation and construct irrelevant variance. And it's frustrating because even though I thought I understood what these concepts mean, okay, my students kept on asking me these tricky questions that I wasn't able to answer. And then I started asking myself tricky questions that I just wasn't really able to answer. So I'll give you a feel for the confusions that I felt. So we'd start off talking about construct under representation and construct irrelevant variance by looking at some definitions. So we started from how Messick defined them. And we've got on the screen a definition from his 1989 paper. It says the two major threats to construct validity are construct under representation. That's when the test is too narrow, fails to include the important dimensions or facets of the construct, and then construct irrelevant variance. And that's the test containing excess reliable variance, making the items or tasks easier or harder for some respondents in a manner that's irrelevant to the interpreted construct. Okay, so we start off from the definitions. But then my students would ask me tricky questions like this, you know, so the first one, so you've got these two terms and you've kind of started off by calling them the twin threats to validity, but they don't really look like similar concepts. They don't look like they're talking the same language. Underrepresentation on the one hand, relevant variance on the other. They seem like different kinds of things. How do they go together? Where's the yin and the yang in that? When I'd ask myself particularly tricky questions, and I found the definition in red the hardest of both of those definitions here when it was talking about construct irrelevant variance. And I read this and I say, well, the test contains excess reliable variance. And I'm thinking, well, how is it that a test contains variance? What does Samuel Messick mean by that? You know, isn't variance a statistical concept to do with scores? You know, similar kind of thing. It contains excess reliable variance, making items or tasks easier or harder. What does that mean? How is it the variance makes items or tasks easier or harder? Don't quite get it. My students, again, they come back and ask me tricky questions like this. So construct irrelevant variance, it's excess reliable variance. So does that mean that CIV is the same as measurement bias? And I'm thinking, well, maybe. And some people in the literature do think like that. But I don't know. Why have we got two words for the same thing? I don't know. Similar kind of thing, tricky kind of thought process. So what about unreliable error variance that's caused by construct irrelevance? Is that construct irrelevant variance or not? I don't know. And the flip side of that, when you've got construct underrepresentation causing reliable excess variance, is that both construct underrepresentation and construct irrelevant variance? So many questions. I just ended up scratching my head and thinking, well, maybe it's not entirely me. Maybe there's something not quite right or not quite accessible enough about these explanations, these definitions. We've got some Samuel Messick. So that's when I set myself a challenge. And the challenge was to see if I could provide a slightly more commonsensical explanation of construct underrepresentation and construct irrelevant variance. And that kind of explanation, an explanation of the sort that my grandmother might be able to understand. And I got that idea from Albert Einstein, I think, who said something to the effect of, well, if as a scientist you can't explain it to your grandmother, you don't understand it. Okay, so I've got to be honest. My first attempt at a grandmother explanation didn't entirely work. I thought I might be able to model these two concepts on the idea of teleportation, okay, and more specifically on the idea of David Cronenberg's movie, The Fly. And this is a great movie. David Cronenberg, one of my favorite directors. It's the story, you can see it here, of a brilliant but eccentric scientist who begins to transform into a giant man-fly hybrid after one of his experiments goes horribly wrong. Yeah, so the central idea here is teleportation. It's the idea that he had these two pods, telepods, he was trying to teleport an object from one of the pods to the other one. And to cut a long story short, Seth Brundle, so Seth Brundle is the mad scientist here, he does actually manage to get this teleportation system working. And he starts off transporting objects, and I think he transports a baboon as well. And then, because he's a mad scientist and it's job to do things like this, he decides to transport himself. And that's where it all kind of goes a bit pear-shaped, or fly-shaped, as the story indeed indicates. Because what happens is that a fly flies into the telepod alongside him just as he presses the button to teleport. Okay, so what happens is both he and the fly teleport together, and their genes become like inextricably linked, and then they essentially just become one creature, which is the Brundle fly. So in my kind of weird mind, that seemed like a perfect metaphor for construct irrelevant variance. It's when your assessment is part signal and part noise. It's like part Brundle and part fly. Okay, well, again, to cut another long story short, I came to the conclusion that my metaphor didn't really work very well. It certainly didn't work for construct underrepresentation. I ended up having to extract bits of Brundle's body, and that it wasn't in the movie. It might have been an interesting plot twist. It might have been better than the actual Fly 2 story, maybe. But anyhow, I ditched the teleportation metaphor. But I decided that there might be something useful to salvage in that idea, and particularly something related to the idea of signal processing. So that's when I started on my second grandmother explanation. In order to make this work, though, I decided I needed to go right back to the basics of educational assessment, and also right back to the basics of validity. So I've already shown you lots of different definitions of validity, and there's plenty more out there. But I'm kind of working now on the hunch that you can probably boil most of them down into what I suggest is this basic idea. Yeah, the idea that validity is all about assessing the right thing in the right way to produce accurate and useful assessment results. And again, if I'm going to explain validity to my grandmother, that's the kind of language I'll be using. So that's my starting point for this exercise. And it takes us to the next question, which is, well, what is the right way to design any particular assessment? And I'm going to use that question, the design question, to structure the rest of this session, the rest of our journey here. So question, how do we decide the right way to design any particular assessment? So might it be by written examination with a high level of control over your conditions, assessing just a sample of your learning outcomes, not all of them? And as you can see here, I've indicated that this is the typical approach that we adopt in England to assessing academic type qualifications. But on the other side, the other hand, we've got the idea, well, maybe instead we should be using performance assessments, authentic performance assessments. Maybe we shouldn't have such a high level of control over our admin conditions. Maybe we should actually be assessing all of the specified learning outcomes, not just a sample. And that's our typical approach to assessing vocational qualifications in the UK. And that's called competence-based assessment, as we know it. And I'll come back and say a bit more about that later. But the question here, two different kinds of approach. How do you decide what's the right approach? Well, I think that you might think of it as the classic response to this question, what's the right way to design a particular assessment? I think it probably goes something like this. It probably goes, well, you start by determining the specific purposes that are driving the assessment. So, is it for placement? Is it for selection? Is it for something else entirely? Then you've got to think about the particular conditions of the assessment. So what kind of learners are you assessing? What are the stakes under which it's being taken? Are there any other constraints as well? Have you got any money? And then you can think through the most significant threats given those purposes and conditions. And when you factored all of those things together, you can build the features and processes into the assessment to ensure that it achieves what it's supposed to achieve as effectively as you possibly can, given the circumstances that need to be accommodated. Okay, so I think that's the basic logic of how to decide the right way to design an assessment. But again, wanting to go back to basics, I want to go a little bit deeper than this. So I want to consider some questions like this. How to specify the general goal of educational assessment, not the specific purposes. How to model a general goal like that, as simply as we possibly can. And then how to model threats to achieving a general goal like that. And it's from that third question that we're going to get to different kinds of ways of thinking about the two major threats to validity. Okay, so that's where we're going to go next. So this is my answer to the question of what we're trying to do when we assess learners. Yeah, and my answer is that, well, basically we're trying to measure them. So a general goal then is to measure how proficient a learner's become in a particular subject domain after they studied that subject for a while. Okay. So generally speaking, we want results from summative educational assessments, and I'm only really talking about summative educational assessments here, not formative ones. We want them to tell us whether one learner has acquired more or less proficiency than another, that's a relative judgment, or whether any particular learner has acquired enough proficiency, and that's an absolute judgment. You might give it a pass. Okay, so that's the idea that I want to develop here, this idea of measurement in education. And you're welcome to take that as literally or as metaphorically as you like, just as long as you're happy to run with me for a while. Okay, so if you run with me with the idea that educational assessment's basically about measurement, then how can we model this measurement process as simply as possible? Well, I think that the simplest way to model it is in terms of information transmission. Okay, so in other words, educational assessment is all about using an assessment procedure to convey measurement information. And again, that's measurement about information about a learner's level of proficiency in a domain, and it's transmitted from the learner on this side to the user on the other side via the assessment procedure. Worth emphasizing that both of these characters here are active participants in this measurement process. So I'm going to explain what I mean here by using a metaphor, and that's my signal processing metaphor. So the idea here is that any assessment procedure is basically just one long signal, okay? The job of the signal is to transmit information from the learner to the user, okay? And it happens like this. First of all, a learner responds to a set of tasks. Then an assessor takes the responses and marks them. Then those marks are aggregated to an overall result. And then finally, a user interprets the result as a level of proficiency. So there's a variety of different stages in the assessment procedure through which that information is transmitted from one to the other. And just to emphasize again, all of the characters here, they're active partners in this construction process. So it's the responsibility of the learner to construct a representation of themselves, if you like, in the tasks that they see before them. And then again, the assessor constructs the next point. And finally, the user constructs the measurement itself, if you like, the measurement interpretation. So it's all about an active process of information transmission. Just to emphasize, here's the same thing in terms of measurement information. So first of all, task responses, the measurement information about the learner is encoded in a set of responses. Next step, pass down the production line, if you like, measurement information re-encoded in a set of marks. Next step, it's re-encoded again in an overall grade. And then finally, it's re-encoded in an interpretation. And it's this final interpretation that I actually think of as the measurement, not the result. It's actually the interpretation at the end that's really the measurement. So to summarize then, okay, educational assessment, it's all about transmitting information, a process of presenting, extracting, interpreting, and representing information about a learner and their proficiency in a subject domain. So it cycles through these successive phases: measurement information encoded in responses, marks, grade, interpretation. And hopefully, if each successful representation is faithful to the one that preceded it, then the final interpretation, that's the measurement itself, that's going to be accurate. That's the theory, if you like. And I'm going to use that theory to now see if I can make sense of construct under representation and construct irrelevant variance. And then I'll show you some pictures, because I did promise you some of those, didn't I? So, okay, so assuming that any procedure, then any assessment procedure is just one long signal, and assuming that it's the job of the signal to transmit measurement information from one side to the other, from the learner to the user, what would it mean to have a valid assessment procedure? Well, the way I think about it, a valid assessment procedure is one that ensures that all of the necessary information on learner proficiency is encoded and stays encoded in that signal. So it ensures a saturated signal, saturated with information about the learner. Yeah, and it's a procedure that also prevents that information from becoming corrupted. Okay, so it ensures a pure signal, if you like, so unaffected by noise, unaffected by interference. And if you think about validity like that, you can think about threats to validity like this. So threats to validity might arise whenever an assessment procedure either fails to capture or elicit all of the necessary information on learner proficiency. That's what I'm calling threats of signal deficiency, because the signal's deficient of information. And that's my version of construct under representation. Or it captures noise or interference. Okay, so that's my threat of signal contamination, which is my version of construct irrelevant variance. And I don't know, you might disagree, but this helps me to think about the two twin concepts in a way that makes them look a bit like each other, that makes them feel like they're working as yin and yang in harmony together. So that's the two major threats to validity then. First of all, not getting enough measurement information. Secondly, getting your measurement information corrupted. And we can go a little bit further than this actually to see if we can subdivide these twin threats into lower level threats to validity. And that's what I'm going to do now. Okay, so on the left-hand side, I've got my sub-threats. So 3 signal deficiency sub-threats and 2 signal contamination sub-threats, noise and interference. And on the right, we've got my big pictures that I'm going to use to kind of illustrate the characteristics. We're going to take these sub-threats, we're going to take them one by one, and we're also going to see if we can work out what they might look like in assessment terms too. So let's go. This is my first signal deficiency threat, and I'm calling it incompleteness. Okay, so it's when the signal, the assessment procedure, fails to convey information on all of the elements of learner proficiency. And again, by way of analogy, you've got a picture here that's missing critical information. Okay, and without that critical information, I'm guessing it's probably quite hard for you to work out who that person is. Maybe some of you have got it. Well, it looks like a fairly attractive person, doesn't it? It looks like a woman. They've got pearls. Maybe it's a princess. We'll see. Okay, so this is an example. This is a real example of signal incompleteness from the Key Stage 2 test. That's England's primary school leaving test, if you like, in English, from about the period around the 2000s. We call them our SATs, although we're not actually allowed to call them that, but everyone does. Okay, so at that point in time, English, according to our national curriculum, was defined in terms of 3 equally weighted components, okay? Defined in terms of reading, a third, writing, a third, speaking and listening, a third. But the English test that was administered at the end of primary school, that only had 2 components. It had reading and writing. There was no speaking and listening at all. Yet it still called itself a test of English and it awarded a level in English. So it strikes me that that's like a prima facie case of signal incompleteness, because the test, the English test, it carried no information at all about how learners differed in terms of speaking and listening. Okay, so the underlying principle here, I think it's fairly straightforward underlying principle. The underlying principle here is the less information you have, the more potential for error there is. So again, I'm guessing you probably can't tell who the person is from this slide, but I'm going to add in more information about the person. Okay, so you can see a bit more of her face, and I'm guessing that some of you will actually be able to work out who it is now. Now I'm going to add in all of the information about the person's face, and hopefully you'll be able to see that it's not a princess, it's Angelina Jolie, isn't it? So what does this principle tell us about assessment and the ideal approach to assessment? I mean, does it say, for instance, that the ideal approach to assessment is to gather as much information as you possibly can about learner proficiency? Well, I think it does. I think it does, at least in theory. I think it says more information, less error. That's got to be a good thing. Now, as I mentioned earlier, competence-based assessment in England is kind of famous, or again, perhaps infamous, for gathering very large amounts of assessment evidence. Yeah, it requires every single learning outcome related to the construct to be assessed and achieved in order for a learner to be judged competent. So you can see on the slide, the way in which our vocational qualifications tend to work is that the overarching construct will be broken down into units, and each of the units will be broken down into learning outcomes. There's 2 for each unit here. Sometimes there's 10, sometimes there's 20. And each of the learning outcomes has loads of different assessment criteria associated with it as well. Okay. So the idea here is that we assess everything that's important to the construct after having deconstructed it. So does that make it the ideal approach to assessment, because it's capturing such a huge amount of information about learner competence? Well, I think it's fair to say that gathering this much evidence is a strong part of competence-based assessment. But the point that I want to make is that even competence-based assessment doesn't necessarily capture all of the relevant measurement information. I'm going to lead us now into our second signal deficiency threat to illustrate that. So this is the threat, I've called it disconnectedness. Okay, so it's when the signal, the assessment procedure, fails to convey information on the organization and coordination of the elements of learner proficiency. So in this picture, it kind of looks like we're not missing any of the information, because actually all of the bits of Angelina Jolie's face are there. Just they're not all in the right order. They're not organized right. And it's still actually quite hard to tell who she is from that picture with the information organized like that. So I think that's kind of what Doug Richard was getting at when he wrote this, which is his review of apprenticeships in England back in 2012. And he said things like this. He said, employers tell me that individuals can tick off the many tasks involved, but not at the end be genuinely employable and fully competent. Yeah. So as I said, like, it's the simplest versions of competence-based assessment, they really do just reduce to list ticking. It's a very comprehensive approach to assessment. It's an exhaustive approach to assessment. And that sounds good, but it might not be entirely good if there's more to competence than just the sum of its parts. And that's the point that I'm trying to make here. So to emphasize that, I want to read you a quotation from Michael O'Rourke, because I think this expresses a really fundamental principle, actually, of human competence. Michael says, analysis of required competencies is very important when preparing an assessment specification, but treating them as separate bundles of knowledge and skills for assessment purposes fails to recognize that complex professional action requires more than several different areas of knowledge and skills. And the critical point, they all have to be integrated together in larger, more complex chunks of behavior. So as well as being like a principle of human competence, if you like, I think this is also actually a critique of much of what passes for educational assessment today. And O'Rourke isn't the only scholar to make this point. I found, essentially similar passages in articles by Samuel Messick in 84, Roy Sadler in 87, Wood and Power 87, Miss Levy 93, Van der Vleuten 96, Brighton Scardamalia 2005. This is lots of very clever scholars from all over the world saying essentially the same thing. It's a really important point, and it's an issue that we haven't really managed to grapple with very well in educational assessment today, I think. I think it's true that we don't often do human competence justice in assessment. Maybe then we could do it more justice if we made more use of simulation. Okay, after all, holistic assessment, coordination, integration, it's right at the heart of simulation. It's all about coordinating these elements of knowledge and skills in complex, intelligent actions. Well, again, yes, I think holistic assessment is a really strong selling point of simulation. But again, simulations, they aren't necessarily perfect in terms of collecting measurement information. And that brings us to our third signal deficiency threat, which is abstraction. So abstraction here, that's when the signal fails to convey information on learner proficiency in a way that preserves detail and trueness to life. So in this picture, there's kind of a sense in which we're not missing information because we've got all of the relevant bits of Angelina's face, and they're all in the right order this time. They're just at a very large grain size. And again, it's still hard to tell who she is from the picture. So I think this idea of abstraction, it kind of resonates really nicely on the literature on authenticity in educational assessment. So that literature reminds us that even simulations, they aren't entirely authentic. Well, after all, by definition, a simulation is only a simulation of real life. So this is an example, an assessment example of abstraction. It's an example from a study by Penny Hoy Mack, where her participant observed when comparing simulations and observations. She says, so in the simulations, you're always doing it in a room, where it's not raining, and you haven't got all the blowing, and you haven't got all the fire trucks and everybody that's at the scene as well. So, I mean, the point here is that simulations, they do capture information, but ultimately they only capture information on how a learner responds to a simulation of real life. They don't necessarily capture information on how a learner will respond to the same challenge were they to face it in everyday life. Okay, so following that line of reasoning through then, does that mean that we should only ever be using observational assessment? So we've got work-based observational assessment in this slide in order to extract our measurement information. So again, well, observational assessment is very good at providing information, but it's got its own problems, of course. For instance, observational assessment, it can present us with what you might call a classic information processing overload dilemma, because it's true that authentic contexts, they do present more relevant information, but they also present more irrelevant information, present more information in total. And that can be hard to deal with from a cognitive perspective. It can make that process of extracting information, the relevant information, very much more complex, very much more error prone. So that introduces our first signal contamination threat. And the first threat here I'm calling noise. It's when the signal's corrupted by noise which distorts or obscures the information on learner proficiency. So I was going to say you can see from the picture. You possibly can't see from the picture that absolutely all of the information about Angelina Jolie's face is there. Yeah. Problem is it's swamped by noise. The noise, it can creep in at any stage in the assessment process. So noise can creep in when learners respond to tasks. I've got an example of that here. So this might be a question from an assessment coordinator qualification, for example, that asks you with the prompt, the correlation coefficient found by correlating student scores on a classroom math test with their scores on a standardized math test is called a validity coefficient, a B, index of reliability, C, equivalent coefficient, or D, internal consistency coefficient. So what's the answer to that? And more importantly, how do you know it? Okay. So, I mean, as your assessment folk, you might well know that the answer is A, validity coefficient. But how do you know that? Well, one reason for knowing that is because you actually know it and you have the information that's been tested by the question. But another way of getting the right answer is just by looking at the grammar of the prompt. Because it asks on a standardized math test is called a index of reliability. No, can't be that. A equivalence coefficient. No, can't be that. A internal consistency coefficient. The only one that actually fits with the grammar of the prompt is validity coefficient. Yeah. So the point here is that even learners who don't actually possess the ability that's tested by the item, they might end up getting a mark. But the mark in this context is not conveying genuine information, measurement information about the learner. It's just noise. Okay, so this is another example of noise creeping into the process, this time when an examiner is adding up marks, maybe. So, well, certainly back in the day, you were doing everything on pen and paper. Examiners had to add up the marks after they'd marked each of the questions. Back in the day, this was all done manually, and examiners often made mistakes, and sometimes they made lots and lots of mistakes, to the extent that sometimes they made it into the headlines of newspapers. The point is simply that, once again, when an examiner adds up marks incorrectly, that's noise contaminating the signal. So the signal might have been pure up to that point in time, okay? But as soon as the marks get added up incorrectly, they're contaminated by this noise. Okay, then finally, this is our second signal contamination threat, which I'm calling interference. So signals corrupted by interference, which distorts or obscures the information on learner proficiency. So the idea here is that the assessment procedure does capture information, just not necessarily the information that it's supposed to be capturing. So I'm going to try and illustrate that here on this slide. So the thing that I'm trying to illustrate here is the halo effect. So the halo effect is like when your overall impression of a learner kind of interferes with, taints the specific judgment that you're trying to make. So let's assume here that we're trying to make a judgment about the learner's reading ability, but we get distracted by how smiley she is, how enthusiastic she is, and that information interferes with the judgment that we're trying to make. So we end up giving her an A when she should really have had a B. Yeah. So the point being here.
Paul,
yeah,
this is Mary. Just wanted to let you know there's 15 minutes left in the webinar.
That's perfect. Thank you. So the point here is, again, we captured interference here. So it's information on the learner's smiliness, in addition to information on her reading ability. So it's inflated, artificially inflated, that grade. This is another example of interference, but we can skip over that one. It's basically the same thing, but this time caused by cheating. Okay, so there you go. All you have to do then is to eliminate all of these threats to validity, and you've got a perfect assessment procedure. But of course, that's not really what this framework's for. This framework is for helping you to understand how your assessment can go wrong, and then how you can design in trade-offs that will optimize the process. So these are the kinds of trade-offs that, the kind of classic trade-offs we're used to making. I just want to put them really in terms of measurement information. So one of the trade-offs you might make is between the desire to create really long tests that sample a lot of content versus the ability of candidates to sustain concentration and effort if your test is 6 hours long. Just put in terms of measurement information, that's about, well, we want candidates to provide as much measurement information as possible. But on the other hand, candidates will find it harder to produce an uncontaminated stream of measurement information, if you like. Okay, so it's a trade-off we're used to making, but this time just expressed in terms of measurement information. So again, all this is giving us is just a little thinking tool. This is just a different kind of representation of the thinking tool. I'm calling it a framework for trading off pros and cons of these contrasting design decisions. So, I'm pitting here multiple choice tests against performance assessments. So multiple choice tests, they're quite good at combating the threat of incompleteness because, they've got small tasks and they can have a lot of them. So they can cover that range. Performance assessments, on the other hand, not quite so good at combating the incompleteness threat because they tend to be big tasks. Okay, so you can only have a small number. But then pit that against the disconnectedness criterion, you find exactly the opposite, because multiple choice tests, because they are atomistic and chunked up, they're not very good at assessing that connectedness. Whereas performance assessments, on the other hand, they're all about assessing that connectedness. I'll skip this slide too, actually. So that's my big picture story of validity. Okay, 2 major threats to validity, which I'm calling signal deficiency, that's construct under representation, construct irrelevant variance, which I'm calling signal contamination, brought to you in association with the signal processing metaphor, and of course with Angelina Jolie. And apologies to Angelina Jolie for disfiguring and dismembering her face so savagely. I just hope she'll appreciate the pedagogic value of the process. I'm just going to end though, just in case you were wondering whether any of this helps me to answer those kind of tricky questions about the twin threats alongside reliability and bias and so on. Does it help? So this is my yin and yang kind of formulation of the relationship between these various concepts on the slide. So the way I describe it is like this. So signal deficiency and signal contamination, I think of them as the 2 major causes of error in educational assessments. So I think they're basically causal concepts, and they're fundamentally really related to assessment processes. And what do they help us to do? Well, they help us to guide assessment design decisions in the main, I think. Whereas unreliability and bias, I think of these as the 2 major manifestations of error in educational assessment. So I think of them as statistical concepts which are related to assessment results, and they're really good for guiding assessment evaluations. What that means then is that both signal deficiency and signal contamination can either cause unreliability or bias, and they do so in the same way by either inappropriately inflating or deflating the measurement outcomes. So unsystematic inflation or deflation, unreliability; systematic inflation or deflation, bias. And on that note, I'll leave it. If you're interested in finding out more about this, I've got a paper in EMIP, and of course you're more than welcome to email me if you'd like to carry on the conversation. So I'll end there, Mary, and I'll see if I can get out. Oh, no,
So thank you, Paul. That was great. If anyone has a question I'd like to ask, if you could type your name in the chat and I'll call on you. I think that would be easier than a lot of people unmuting and asking questions at once. So Paul, while we're waiting, have you tried this on someone else's grandmother yet?
Do you know what? I haven't tried it on any grandmothers yet. I'm a bit embarrassed to do so, just in case it doesn't work.
Oh, okay.
But I really appreciate feedback from the audience. What do you think? Does it help you to understand these concepts a little bit better? Does it ease you out of some of the confusions that I found when I was trying to teach these ideas? Yes, good.
Stuart asks if you've shared this with practitioners.
So I have shared these ideas a number of times. So I've shared them in different contexts, and I have shared them with people working in the vocational world. And I have to admit, they seem to have gone down fairly well there. I think sometimes folk who work in the vocational world, who work on competence-based assessment, feel that they talk a different language from people who work in the testing world. And what I've tried to do with this framework is to introduce concepts that can be applied in essentially the same kind of way to quite different kinds of assessments. So I think it's helped them to be able to understand the kind of language that might be talked about in a testing context, but in their own context. So it seems to have gone down fairly well there, and fingers crossed.
So Anne, would you like to make your comment?
Yeah, Paul, I'm not a grandmother yet, but I'm certainly of that age. And I certainly found the signal metaphors that you used a hell of a lot better than the old-fashioned target practice type imagery.
Yeah.
So thank you for that, because it certainly is much clearer.
That's appreciated. Do you know what, Stuart and I, when we were doing our work on validity some years ago, we looked at those target metaphors and we thought, you know, can we use those to teach our students? And the more we looked at those targets, we're all familiar with the targets, aren't we? That with the arrows going into the center or being clustered, and so we couldn't extend them. We couldn't make sense of what they actually meant in an assessment context. They had some sort of holistic impression of something useful, but we couldn't really get below the surface. And that was part of the motivation for this kind of thinking in the presentation here, to get a metaphor that just could be used a bit more to make a bit more sense of what's going on in an assessment context. So yeah, thank you.
And Stuart, do you want to ask your follow-up question?
Hello.
Hey, Stuart.
Hello. Yep.
Hello. Oh, sorry.
Hello. Yeah. Hello.
Hiya.
So, I'm trying to give Stuart an opportunity to ask his follow-up question. Stuart Shaw.
I have a question.
Okay, we'll get to you in a minute. Okay.
Okay. I'm Mark Ugoke from NAPTEP, Nigeria. I want to find out from Paul how we can reduce the threats to validity in authentic or performance assessment.
Sorry, I didn't capture that. How can we
reduce threats to validity in performance or authentic assessment?
Yeah, so this is one of the great challenges, isn't it? Because we want these assessments to be as authentic as possible, ideally, because what they do, an authentic assessment, it bombards you with all of the relevant information. But the problem, like with that picture of Angelina Jolie with all the noise in it, is you get bombarded with tons of other information as well. But it strikes me that that's not necessarily an argument against performance assessment. What it's an argument for is to work out techniques for extracting information from noise. Okay, so this is a problem. It's not unique to the context of educational assessment. It's a problem that's faced in all sorts of disciplines. And it's a problem that's actually been solved in other disciplines in ways that we probably haven't even imagined. So I think my answer to the question would be, let's work out how other disciplines solve problems of information extraction and see if there are lessons that can be learned. I don't actually know the answers to those questions yet. All I've thought about is that this is a really good avenue for an assessment professional to start exploring.
Thank you, Paul. I appreciate that.
Okay.
Thank you, Paul. I appreciate that.
Thank you.
Thank you. Stuart, would you like to try to ask your follow-up question again?
Thank you, Mary. Just a very quick question, Paul. As you were speaking and responding to the first question about practitioners, and also throughout the entire duration of the presentation, it was very clear to me that the metaphor you're using is a wonderful pedagogic device. There's no question about that. But I wondered, is there a sense in which the metaphor works better in certain situations or for certain assessments? And the underlying motivation for that question comes from the work that we've been doing on fairness, Isabel and I. And we've been focusing in the past on educational assessments. And now, as you know, we're turning our attention to vocational assessments. And the senses of fair that we've identified for educational assessments are not quite as well fitting when it comes to vocational. And I wondered if perhaps the metaphor is strained or doesn't altogether fit with certain kinds of assessments, such as vocational.
Well, possibly, but I hope not. So the intention of this model, again, is to be as general as I can possibly manage. And what I'm hoping is that it is a model that can be applied in a similar kind of way across similar kinds of assessment. I've put these ideas to people working in the vocational sphere, and one of the things I wondered maybe is that, whether the idea of measurement would ring true with them. But actually it seems to, the idea of measurement seems to ring fairly true with many of the vocational folk that I've spoken to. When you put it as simply as determining whether or not a learner has sufficient competence. The critical thing in any kind, whether you're getting all of the right information on a learner's competence. And that, I think, is handled fairly well by the metaphor. So, I mean, you might be right. Let's see how it goes. I welcome feedback from folk around the world, but I'm keeping my fingers crossed that it works as a good metaphor across the board.
I'm just wondering, as one final question, really. Is contamination easier to identify, for example, for educational assessments compared with vocational?
I don't know. I don't know. I think there's a strong argument for saying it's actually very hard to identify much of the time, regardless of the qualification type. So I don't know. Do you have thoughts on that?
It just seems to me that given the authenticity of certain vocational scenarios and the complexity of those scenarios, there's more scope for a number of imponderables relating to contamination that have to be accounted for. It's just my first thought.
Yeah, I mean, that's absolutely true to the extent that there's so much more information. But I mean, it's also the case that it's clearly there in all of the tests that we design, even the simplest of the multiple choice tests, as I was kind of indicating with the example of construct to elephant exists.
Okay, I think we have time. Well, we don't really have time, but there's a very interesting question posed that if people have a moment to stay on, I think it would be good. It's from, and I apologize for my pronunciation, Ifoema Izugo Abane. I'll just read it for quickness. Thanks for a great presentation. In today's culture of new normal, where more online assessment is recommended, you envisage more threats to validity here? Oh, well, I mean, there's going to be plenty of threats to validity, isn't there? But I guess they're probably not going to be. They're not going to be lots more. They'll just be slightly different versions, I guess. So I gave an example of. I didn't read through the example of cheating. So cheating in the key stage 2 writing assessments, where the teacher was literally going through scripts and correcting things before it went off to be marked. But there's going to be all sorts of construct irrelevant variance problems, all sorts of signal contamination problems that we're going to encounter anew in online contexts. So yeah, a useful framework, hopefully, for unpicking some of those new challenges that we'll face. Well, thank you very much, Paul. Excellent presentation and questions and answers. So As a reminder, we'll be posting this recording on the IAEA website, and we'll be in touch about the next one, which I think at this point will be in December, but we'll certainly let you know. And thanks again, everyone, for taking the time to attend.
Thank you.
Bye-bye. Have a good day.
Bye-bye.
Bye-bye, Paul, and thank you for the presentation.
My pleasure. Thank you.
Bye-bye.
Thank you.
Thank you so much for that presentation.
Hello.
Okay, I'm going to end the session now. Thanks, everybody.
Thanks.
Bye-bye.
Bye-bye.
Bye.
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 Bye. Bye.